All right, so here we're in chapter 8 now, and I might have done this last time as well, okay? But I feel better going through it again. Not going through what we did last time again in chapter 8. So from here, what we're going to see is what's called a system, of equations. That's what we're going to see here, a system of equations. We're going to see what it is. Mostly what we're going to focus on is what's called a linear system. That's what we're going to focus on. With a linear system, basically the variables all have exponent 1. It's not like in a quadratic equation where you have something like x squared plus 2x is 4. It's not like that. Here, the variables have exponents that are all equal to 1. So you may see something like 5x plus 6y equals a number, that kind of thing. And we're going to see different ways to solve this kind of system, this system of linear equations. We're going to see substitution, how to solve these graphically. I'll go through Desmos as well. I am sorry I didn't go through Desmos earlier in the course, but I'll go through it now. And we'll also see a method called elimination. I'm mostly going to focus on substitution and elimination, mostly because with graphing, you have Desmos. And since we're in the online system, since we're in an online class. If I was teaching in class, if we were on campus before this pandemic happened, then I probably would have you graph, by hand. But since we're not in that, we're in an online class, I'll focus on substitution and elimination. I'll focus on that. And what we're going to see is actually a little bit of linear algebra. I forgot what course it is here at SUNY Oneonta, but there is a course dedicated to solving these kinds of systems. They use matrices and stuff. That's a whole different story. So we're just getting a taste of it. All right. So again, we're going to take what we did in the first chapter here, and we're going to take it a step further. There we considered equations in 1 variable and equations in 2 variables. Now we're going to look at 2 equations and 2 unknowns. But any collection of equations in the same variables, that's called a system of equations. So any collection of equations in the same variable is a system of equations. And here what we're going to mostly look at is linear equations in variables x and y. But you actually could go beyond that, up to 3 variables, 4 variables if you wanted, but we're not going to do that here. With this system though, A, B, C, D, J, K, those are all fixed constants, numbers that is. They're real numbers. A and B can't be 0 at the same time. D and J can't be 0 at the same time as well. So A and B cannot both be 0. D and J cannot both be 0. If that happened, then you would basically be killing off an equation. You would only have 1 equation to deal with. We want to deal with 2. And what we want to do here is we want to solve such a system, meaning we want to find the solutions. A solution is a solution to both equations. In other words, a solution to this kind of system, it's an ordered pair that is a solution to both equations. So it has to be a solution to both equations. Since we have 2 variables, our solution is going to be an ordered pair of numbers. So that's what we're going to have. So here's our first example here. Let's say we have this system and we want to know, is 3, 1, is this a solution? Well, we want to know, is it a solution to both equations? That's what we want to figure out. Let's see. Well, if x is 3 and y is 1, in the first equation, we get 6 minus 1 is 5. 6 minus 1 is 5. Okay, well, that's true, right? That's true. And since this is true, this is a solution to the first equation. What about the second? Well, if x is 3 and y is 1, we have 3 plus 2 times 1, which is 5. 3 plus 2 times 1 is 5. Well, that's also true. So 3, 1 is a solution to both of these equations. Hence, it's a solution to the system. So that's what happens here. With 4, 3, let's try that. Well, if x is 4 and y is 3, right? What happens? In the first equation, we get 4 times 2 is 8. 8 minus 3 is 5. Well, that's true. What about the second? We have 4 plus 2 times 3. But 4 plus 2 times 3, what is that? That's 4 plus 6. That's equal to 10, which is not equal to 5. So this equation is false. In other words, 4, 3 is a solution to the first equation. It's not a solution to the second. It's not a solution to the second equation. And because of that, it's not a solution to the system. So you have to be a solution to both equations, is what I'm saying. Again, that's just what it means to be a solution to this. What's nice, okay, so we have that. Okay, we went through some terminology. Again, math is just like any other science, right? You do have some terminology and definitions. Well, here's some more. What's nice about these systems of linear equations that we're dealing with, there's only one of 3 possibilities regarding the number of solutions. There's either no solution, exactly one, or infinitely many. So let me say it again. There's either no solutions, only one solution, or infinitely many solutions. Those are the only 3 possibilities. So what's nice is you're not going to get exact. If you find 2 solutions, for instance, there has to be infinitely many. That can happen. And if the system has no solutions, we say it's inconsistent. Again, this is just terminology people use. So inconsistent means there's no solutions. The solution set, though, is empty in that case. The solution set, I'm not going to focus on too much. I'm only mentioning it because the book does. But it is empty, though, in this case. And if there's at least one solution, it's consistent. So if there's at least one solution, then it's consistent. Okay, that's cool. Well, if there's infinitely many solutions, though, so you have infinitely many, well, then in that case, the equation, right, the equations in the system are dependent. The equations in the system are dependent. But if there's only one solution, then that solution's unique. You know, there's only one. We call it the unique solution, and the equations are independent in that case. Again, this is just terminology. So if there's infinitely many solutions, we say the equations are dependent. But if there's one solution only, we say it's independent. We say it's independent in that case. Good. Okay, that's fun. Now, this is just some other stuff that can happen when we're solving it. I'll get to that in a minute.